Have you ever wondered what a solar flare is and how it impacts us? The Sun, our very own star, is a hub of cosmic activity. One such activity is the eruption of solar flares, a fascinating and complex phenomenon. These are essentially massive bursts of radiation and magnetic energy that are hurled out into space from the Sun's surface. And while they might seem distant and abstract, these flares can have significant impacts right here on Earth, and yes, even on our daily lives. From influencing our planet's natural light shows, the auroras, to potentially causing disruptions in our technology and power grids, solar flares are a testament to the Sun's profound influence on our world. So, buckle up as we embark on this celestial journey to unravel the mysteries of the Sun. Now let's delve into the science behind these spectacular solar phenomena. A solar flare is a sudden explosion on the Sun's surface. It's like the Sun having a colossal tantrum, throwing out an astronomical amount of energy and charged particles into space. But what triggers this celestial outburst? It all comes down to the Sun's magnetic field. Imagine the Sun's magnetic field as a tangled mess of magnetic loops coiled up like a spring, storing an incredible amount of energy. This energy is primarily stored in the Sun's outermost atmospheric layer, the corona, which is hotter and more volatile than the Sun's surface. Over time, the Sun's rotation causes these magnetic loops to twist and distort. This distortion builds tension, much like winding up a toy car for a race. Eventually, the tension reaches a tipping point, and the magnetic field lines snap, causing a magnetic reconnection. This reconnection is like the release of a wound-up toy car, but on an astoundingly larger scale. When this reconnection happens, the stored magnetic energy is suddenly released, triggering a solar flare. The energy unleashed in a single solar flare can reach up to 6 times 10 to the power of 25 joules. To give you a sense of scale, that's equivalent to the energy of 1 billion hydrogen bombs. This energy propels a burst of radiation across the electromagnetic spectrum, from radio waves to X-rays and gamma rays. Along with this radiation, solar flares also eject a stream of charged particles known as a coronal mass ejection, or CME. These particles, traveling at high speeds, can reach Earth in just 1 to 3 days. While solar flares are a natural part of the Sun's cycle, they remind us of the immense power our closest star wields. It's a fascinating yet humbling reminder of our place in the cosmos. That's a lot of power coming from our closest star, isn't it? Solar flares are caused by the interaction of highly charged particles. This sentence might seem a bit abstract at first, but let's delve deeper to understand the intricacies of these magnificent solar events. The Sun, our life-giving star, is a swirling sphere of hot, ionized gas or plasma, and it's this plasma that generates a magnetic field. Now, this isn't your everyday refrigerator magnet. The Sun's magnetic field is a complex, dynamic force that extends far into space. Picture the Sun's magnetic field as a tangled ball of yarn. The lines of the magnetic field twist and turn as the Sun rotates, and sometimes they can become so knotted that they cross over each other. It's at these points of intersection where the magic, or rather the solar flare, happens. When these magnetic field lines cross, they can suddenly snap and reconnect, creating an explosion of magnetic energy. This explosive process is known as magnetic reconnection. The reconnection point then acts like a colossal slingshot, catapulting particles away at nearly the speed of light. This results in the release of a tremendous amount of energy, equivalent to millions of nuclear bombs, and voila, a solar flare is born. But it's not just the Sun's rotation that causes these tangles in the magnetic field. The Sun's differential rotation, where the equator spins faster than the poles, also plays a significant role. This causes the magnetic field lines at the equator to become wound up, increasing the likelihood of magnetic reconnection and therefore solar flares. Solar flares, as you can see, are not random occurrences, but the result of the Sun's complex magnetic dynamics. The Sun's magnetic field, with its intricate dance of twist and turn, creates these breathtaking spectacles of light and energy. So these awe-inspiring solar events are the result of some pretty intense magnetic activity. So next time you see a picture of a solar flare, remember the cosmic ballet of magnetic fields that make such a spectacle possible. Now, how do these solar flares affect us here on Earth, you may ask? Solar flares, as spectacular as they are, can bring about a myriad of impacts on our planet. And no, it's not just about the stunning light shows we call auroras. One of the most tangible impacts of solar flares is on our technology. The sun's activity, including solar flares and coronal mass ejections, can play havoc with Earth's technology and power grids. These solar storms can cause disruptions in our power supply, GPS, and radio communications. Picture this. You're driving home relying on your GPS when suddenly it goes haywire. Or perhaps you're in the middle of an important phone call and it abruptly cuts off. These scenarios might seem like a mere inconvenience, but in a world increasingly reliant on technology, they can have significant repercussions. Beyond our personal devices, solar flares can also interfere with satellites. These are vital tools for weather forecasting, global communications, and even military operations. A powerful solar flare can damage these satellites, leading to a loss of these essential services. But it's not just our tech at risk. Astronauts out in space are directly exposed to the increased radiation levels from solar flares. This exposure can potentially lead to health hazards, making space travel during periods of high solar activity particularly risky. Yet amidst these disruptions and potential dangers, solar flares contribute to one of nature's most stunning displays, the auroras. You've probably seen these brilliant dancing lights painting the night sky with hues of green, purple, and red. These are caused by electrified particles from the sun interacting with Earth's atmosphere, a phenomenon often triggered by solar flares. The beauty of the auroras serves as a stark contrast to the disruptions caused by solar flares, reminding us of the awe-inspiring power and mystery of our sun. While solar flares can cause some problems, they also contribute to one of nature's most stunning displays, the auroras. Now let's talk about a future event, the predicted solar flare on July 5, 2025. As we journey towards the year 2025, our sun is also on a journey of its own. The solar cycle, currently in its 25th iteration, is expected to reach a solar maximum in the summer of 2025. This means we can anticipate an uptick in solar activity, including the possibility of a significant solar flare event on the 5th of July. Now you might be wondering why this specific date? Well, it's not a wild guess, but a calculated prediction based on patterns observed in the sun's behavior. Scientists use these patterns to predict when the sun might be at its most active. And according to their calculations, the 5th of July, 2025 is one such date. So what might we expect from this solar flare? If the flare is strong enough, it could unleash a coronal mass ejection, sending a wave of electrified, superheated plasma hurtling towards Earth. The results? Well, that could range from a spectacular aurora display to potential disruptions in our power grids, GPS, and radio communications. But there's no need to start building a fallout shelter just yet. While the potential impacts are significant, we have systems in place to mitigate them. Forecasters can issue warnings ahead of these events, giving us time to prepare. For instance, power companies can safeguard their grids, satellite operators can put their hardware in safe mode, and airlines can reroute flights to avoid communication issues. On an individual level, preparedness for a solar flare is similar to preparing for other disasters. Stock up on supplies, have alternative sources of power and communication, and be cautious with generators and charcoal grills during power outages to avoid carbon monoxide poisoning. So, while we can't stop a solar flare from happening, we can prepare and mitigate its impacts. Solar flares are truly fascinating, aren't they? We've journeyed deep into the heart of our sun, uncovering the science behind these powerful eruptions. We've learned that solar flares are caused by intense magnetic activity, releasing vast amounts of energy into space. Their effects on our planet are profound. From inspiring awe with the ethereal beauty of auroras to the potential disruption of our technology and power grids, these celestial events remind us of our intimate connection with the cosmos. We also touched on the anticipated solar flare of July 5, 2025. As we near this date, we can expect an increase in solar activity, culminating in what promises to be an extraordinary display. So, as we conclude, let's keep our eyes on the horizon and our minds open to the marvels of the cosmos. Keep looking to the skies and remember there's always more to learn about our incredible universe.